Hey Techno Studs! In this video, we're going to go over subnetting. It's going to give you that foundational information that we're going to use as we get into our demos. So let's jump into subnetting. In this video, we'll start out by taking a glance into the IP addressing history again. Then what we're going to do is we're going to jump into what it means to borrow bits, and then we'll wrap things up by talking about the subnet mask and what that does for us. In one of my first videos in this course, I really talked about the history of IP addresses. It really gives us a great understanding of where we're going and what we came from. So when I started out, I talked about RFC 760 and how it defined what an IP address looked like. And one of the things it specified was this first octet specifies the network. That's 8 bits, so 2 to the 8th power. That gives us 256 networks, and which is just crazy small because we obviously have way more need than just that. And then the rest of this was supposed to be the host bits, which is way too many hosts for the network that you have, for any network, any one network. So really a change was needed pretty quickly, and that's when the RFC 791 that specified IP version 4 and what IP addresses look like. And so what it did is it broke things down into classes. And we went in depth into how there's a class A, which specifies this first octet is the network address, a class B, where it extends it to 2 octets, or a class C, which is 3 octets. So that is what was specified in 1981. It still only gives us about 2 million, a little over 2 million networks here. So it's still not enough networks for the internet connections which were growing. And so we needed more. We needed more networks, and we didn't need near as many addresses per each one of those networks, host addresses per each one of those networks. So that's where subnets come in. So subnets allows us to break this down into smaller pieces. So we're going to be studying that when we're talking about subnetting. Is essentially just breaking this down into, if you had a class A address, I could draw the line somewhere else and say, this is all going to be the network side of this, and this is going to be the host side of it. So that's what subnetting is. Another way of explaining this is that we are borrowing bits, and we are borrowing bits for the network bits. So what does that look like? This right here is a class A. I know it's a class A because it starts with 10. 10 is within the range of 0 through 127, which is a class A address. Or if I were to turn this into a binary number, the leading the leading digit would be a 0. And so therefore, since this starts out with a 0, then this would be in a class A range. So because it's a class A, I know it's the first octet that's the network address. So what I'm going to do is, let's say I'm given this address. This is the address that I can use. Maybe the internet service provider gave me this, or as we look at it, we see that it's a private addressing. So, so now I have this to work with and split up amongst my network. And maybe I have lots of smaller networks that I need to split this up. So what I'm going to do is I'm going to borrow bits for a network address. So maybe I'm just going to borrow 1. If I just borrow 1 bit, that's going to give me 2 different networks. It's going to give me a 1 or a 0. Or maybe I want to borrow 8 bits. And so now I have 256 networks available to me. So I can draw the line here where I want to do this subnetting. I could even draw it way over here and have a lot of different networks, and then just a couple addresses per each network. This would 2 to the 2nd power is 4. So that gives us 4 options for the host, but we had to minus the network address and the broadcast address. So that only renders us really 2 addresses here. So maybe I just have 2 devices on there. which actually there are a lot of networks that surprisingly have that, but we'll get into that a little bit later. But essentially this is, subnetting is we can draw the line where we want that specifies what are the network bits and what are the host bits. So now we've changed the rules for computers or whatever devices that you are working on. Before, they would just look at this first octet, and from that information, they could figure out where the line is supposed to be drawn. But now we're drawing the line somewhere else. So now the computer needs to figure out where you've drawn that line. We need to tell it. That's what a subnet mask does, is you are going to tell the computer or whatever device you're working on where you're drawing the line. We do that through bits, through ones and zeros. So in this case right here, I'm going to turn a bit on for every place that is going to be the network portion of this. So I'm going to turn all these bits on here. And what it's doing is it's saying each one of those bits that it's going to look at for the network portion. And the ones that are just host portion, we're going to use zeros for. So there you have it. Now we've specified, now by entering in the subnet mask, we've told the computer what it is that, that this is going to be. And then the way that looks is all ones in an octet is 255. So the subnet mask would look like 255.255.255.0. So that's what we would enter in as a subnet mask. So cider notation didn't really come until a little bit later. But what I wanted to do is you're going to start seeing that incorporated into our lessons now. So I wanted to cover what cider notation is. Cider notation really isn't all that difficult. All what it is rather than writing out a subnet mask and presenting it in a subnet mask, you're just going to count how many ones are in the subnet mask, and that's what's going to specify where you've drawn the line. So in this case right here, we've got the address 10.0.0.0, and then we would count the ones, which we've got 24 ones here. So we would say /24, and that's how we would specify that we've borrowed extra bits, and there's the total mask. The total number of network bits is 24. So there you have it. What this is the IP address right here. It is a class A, so typically we would have just the first octet as being what the network bits are. We've drawn the line at another location instead. So then we create, using these bits, we create a subnet mask, and this is what the subnet mask would look like, 255.255.255.0, and then we can write that out in cider notation, which once again didn't come until a little later, but we're going to start incorporating that into our lessons now.